Koh Young are the world's leading provider of SPI equipment in the EMS industry. They also have a strong footprint in AOI inspection, and more recently have started moving into the advanced packaging community. The company plans to launch two newly upgraded platforms this fall. And joining me to discuss these will be Joel Scutchfield, General Manager for Koh Young Americas. Welcome to Galbraith in Conversation. Welcome, Joel. Nice to see you. How are you this morning?
I am great. Nice to see you again, sir. Always good to be with you.
Okay. So you've got a couple of really exciting announcements. It sounds like you've been busy in the Koh Young Development Labs, and you've got two new launches to show us this fall. The first of these is an upgrade to the Zenith platform with the Zenith DS. So tell us, what does the DS stand for?
Well, it's very simple actually. It's simply dual sided. So we have for the past several years offered our AOI tool with an internal inverter flipper, if you will, for a simultaneous, or I should say, sequential inspection of top and bottom in a single machine load, right, where we don't have to incur additional load unload time.
Mm-hmm.
So that has certainly taken us a certain distance down the trail, if you will. But the need for eliminating the actual inverting time is still there. And as cycle times become more critical as time goes on, we realized the need that to overcome that completely was to develop a true dual-sided top-bottom simultaneous inspection system tool.
I see. I
And
see. Yeah. So, so,
yeah,
so by
we
putting a camera at top and bottom, then you get faster throughput rather than having to flip it, because flipping just takes double time, doesn't it? Yeah.
Exactly. We eliminate the flip. We eliminate the need for two systems. We basically are able to do everything top and bottom simultaneously, and that is going to have, we feel, a very significant impact on our customers. Obviously, we know that the through hole inspection initiative continues to grow. So we are going to basically have the ability to inspect both SMT and through hole, top and bottom. So irrespective of where the content lies, we'll be able to address that in that single machine load very quickly, single pass.
Right. Are you seeing an increase in some of the through-hole stuff with the big power electronics coming through?
Yeah, we certainly are. And this has been a trend for some time now, is I think just the industry in general has shifted from the point where SMT is for the most part fairly well wrung out. Let's say, right? We've gotten that down to a fine science. The industry in general. So then you kind of move the target. Where's the next bottleneck? And through hole started becoming very prominent in terms of requests from customers going back several years now. So this was our initiative to go down that path first with the inverter, but there's no doubt about it, and certainly, as you said, the power electronics, EV, data server just continues to drive that even further with heavier, higher clearance requirements on and on. So we feel like it's right time, right place.
Yeah. Well, it makes a lot of sense actually. So the second big announcement this fall is the launch of the Zenith Nova UHP. Now, this is more than just an upgrade, isn't it?
Well, yes, it is. The system itself takes on a little bit different form factor with the 25 megapixel camera. There's a requirement for a little more distance on the top side, but the whole idea is speed. So it is it is still the part of the Zenith platform, but it's going to look just a little bit different than what you normally see from us. But again, the idea is really at the end of the day, faster, faster, faster. 25 megapixel camera to give ourselves a much larger field of view, and the approach there is the fewer fields of view that we have to capture, the faster we're going to be able to process that particular assembly. So yeah, we feel again that there are certain applications where this is going to fit very well, and I think it's going to be very well received because again, it's based on the same technology that we've been using for years. It's just going to give us much more speed, which again is something we've been being asked for. So
Yeah, absolutely. And and as everything gets smaller, of course, the camera technology gets bigger all the time. So it's is a moving target. It's getting
it
continuous
is, yeah.
improvement.
Bigger megapixel cameras and tighter resolutions on
Yeah,
on the XY, right? So driving down to from the 10 to 5 to 3.5, on the Meister series in particular, and
yeah.
even beyond that with some of the other stuff we're doing.
Yeah. Okay. So throughout the industry, the major topic under discussion is AI and how it can genuinely assist the manufacturing and, in this case, the inspection process. So, what are the most recent AI-driven improvements to the Koh Young products?
Sure. No, that's a great question, and it's certainly something that we've been addressing and have been very busy to accelerate development for. We have what we call basically an offering of AI solutions, if you will, tools, and that encompasses everything from our KAP. Koh Young Auto Programming through what we're calling Smart Review, which is an automated system for basically assisting and ultimately making final judgment on the review process. So we basically take the operator dependence out of that piece as well, and then certainly the KPO tools, which we've talked about from time to time over the years, continue to develop the printer tool, which basically gives the customer the ability to take full control of their screen printer for the squeegee speed, pressure, and stencil release variables in that process for an ongoing again hands-off control. And then with the mounter piece, KPO mounter, now from a pre-reflow environment, inspection environment, we are providing feedback to the pick and place system for anomalies found with presence, absence, position, rotation, polarity, again part mark, missing, all of the above, and basically giving the customer the ability to control for feeder, nozzle, spindle, skip, where we're seeing anomalies occur potentially, or anything with regards to missing positional self-correction on the fly prior to creating the solder joint. So again, that's where most of our attention has been placed in terms of the AI usage, and it really lends itself well to each of those pieces as we're specifically with Smart Review. Assessing patterns. That's
Yeah,
basically what AI does.
yeah,
So again,
yeah.
we're very excited about all of this, and looking forward to showing all of it at a greater level as we go into the fall show season.
So with Smart Review, I mean, is it showing up, real improvements in false calls and that sort of stuff, by being able to monitor previous behavior?
It
Is
is,
it
yeah.
showing real, what should I say? Is it assisting the bottom line here?
It is. In fact, it's also a tool that's been under development and under significant testing by some of the largest players out there in the EMS world
Hmm.
over the last couple of years, and we're now to the point, Trevor, where we have some very significant installations, and a lot of people asking for evaluations and bring it in as soon as you can. Let's get started, because there's basically a significant reduction in escapes, in particular in false calls are false calls, but you're not going to eliminate them without basically retraining the operator or taking full control. But we are seeing that as well
Right.
as the models are tuned. So ideally, we're going to use all of this to basically adjust the tolerances in the program so those calls aren't made at all,
Hmm.
and therefore will not need to be judged. And that's really the end game here. But
Right.
yeah, the progress has been very steady, but the results are definitely significant, and
Hmm.
having a lot of our customers asking for more. So
Great, great, great. Well, I'm sure again that's going to be a continuously developing area as well. So, looking ahead into 2027, what are the BHAGs for KY? And what I mean by that, BHAGs is not everybody's familiar with it. It's big, hairy, audacious goals.
there you go.
We
Got
all,
to have a goal, right?
you got to have a goal,
Yes,
exactly.
got to have
So
a goal.
what are the big goals for Koh Young next year?
Sure. Well, I think it starts with what we just described, right? So as these systems are released, the dual sided, the Nova Ultra high performance tool, the faster systems are rolled out and adopted by the market. We will look to expand that. Certainly,
Mhm.
we'll look to make ongoing improvements to those tools, which, as you know, is our MO, a voice of customer. Tell us what we missed, tell us what we can do better, and let's find ways to expand this, particularly into the back end, which is where we're getting a lot of interest in the SMT world in particular. As
Mhm.
again, we've gone from SMT to through hole. Now what else can we do? DPI, combining DPI, and what I mean by that is dispense process with AOI potentially, and again, handling taller components, 120 millimeters,
Mhm.
in terms of clearance, in 60 millimeters in full 3D, to be able to measure these larger parts that we're seeing with the power requirements.
So
And then
you're talking
beyond
about
that,
going into more deep inspection of dispensing, more deeper
yeah,
types of inspection.
that is certainly a part of it, Trevor. The
Mhm.
the Neptune series has been very widely adopted,
Mhm.
for the most part, for standard conformal coating, where we can actually measure thickness on the components and
Right.
the board itself at multiple points on that particular assembly at regular production tack rates, speeds. But we're seeing more new applications that move outside of the standard conformal coating world, with potting, underfill, and other types of dispensed, if you will, adhesives, glues that also need to be measured or are confirmed for presence, absence, et cetera, et cetera.
Mhm.
So we see that as a big area of opportunity, and we've gotten a lot of push to go ahead and combine that technology, especially for the coding in particular on the 2D front, with our standard AOI offering, to be
Yeah.
able to do both, again,
Yeah.
in a simultaneous matter, single machine load.
Mhm.
So lots of activity on the SMT side, certainly in the back end, and we're very focused on that going into 2027.
Right.
And then beyond that, we start getting into that packaging world, in the advanced packaging front.
Yeah, that's an interesting area because I mean, with TSMC, Samsung, Intel, and SK Hynix all chasing different packaging roadmaps. I mean, the big question is whether advanced packaging is becoming a multi-platform market, where the winning tool depends on the job. So, what challenges do you think that's going to bring you as a manufacturer of inspection systems?
Well, I think yes, there's no doubt that the potential is there. That there will be differing needs from differing sectors, if you will, or sects, different
Yeah.
groups, customer groups. And I think we have to take the same approach that we've always taken. It's we do our best to come up with a one size fits all, but in reality we know that one size, it's a bell curve, right? One size fits
Hmm.
the middle. There's always going to be some fringe applications,
Yeah.
and then we try to address those as we go, similar to what we just talked about in the SMT world. We're adding these new features, adding these capabilities as the market says, we need these now. uh, and I think the same thing will happen on the packaging side.
Hmm.
Our forte is really in the system and package world. So what I mean by that is, we're combining the front end, if you will, of the packaging space, flip chip BGA, flip chip CSP, reconstructed fan out wafer level applications with standard SMT into these system and package approaches. And we're really pursuing our existing customer base, who now is showing interest from their development perspective in utilizing these types of technologies in their current systems, particularly on the mil aero side, certainly on the data server side.
Hmm.
So again, I think we're going to see a strong opportunity there, and with those Meister tools, being able to do everything we've traditionally done in our AOI systems, but now applying it to a die or a flip chip, where we're still looking at shiny coplanarity, positional. Chip cracks, micro cracks, et cetera, using again coaxial lighting and some of the additional elements that we bring, telecentric lens, et cetera, that we bring to the to the party for that space to basically accelerate the opportunity and ability to do both. So it's
Hmm.
SMT and that first phase of packaging with those again flip chip, CSP, BGAs, balls, pillars, C4, et cetera,
Hmm.
on either the rigid flex, or excuse me, rigid substrate, or panel, panel or wafer. That's what
Wafer.
the word I'm trying to say.
Yeah, I
Panel,
mean,
panel
panel
wafer.
packaging is certainly becoming a big thing, and for a variety of reasons. It's easier to handle big panels than it is a round wafer, as it were. But I mean, any plans to bring anything out for wafer inspection, or is that in the roadmap, or is that?
Oh, certainly, certainly is, Trevor. In fact, it's not a secret. We introduced the ZenStar platform a couple of years back at Semicon West, and there is ongoing development with that tool. Initially, again, we were looking more at the panel level, right? But
Mhm.
now, from a wafer perspective, we have the ability to utilize the EFEM and the FOOP and fully automated in and out
Yeah.
robotic handling, Class 10 clean room, for again now balls and bumps that are in that, let's say, that 2025 micron feature
Yeah.
size and 15 micron height. So that certainly opens up a new world. That's well beyond even the micro bump, 30 micron threshold range, and that's through the use of a new development, the Zeta probe, which gives us that opportunity, and certainly we see that driving even lower as time goes on. But for now, uh, maximizing the capabilities of that Meister for those system and package applications, while we roll out the ZenStar with the Zeta probe and that 1.9 micron capability to drive down to the advanced miniaturization that's going on in that space.
Right. Well, a hugely exciting time to be in the industry, Joel, and I'm
Yeah,
sure.
it's funny. Look, it's not going away, right?
No.
And I've been saying this for years, right? I mean, it's obvious. What once was mechanical is becoming electrical, and now this world that we're in, with the AI boom and space and
Yeah.
all of these other things, is
Yeah.
just driving it to the next level. Autonomous. I mean, you
Yeah,
name it.
I know.
I think for those in this world, working in this world, we're going to have more than enough to do for the foreseeable future, and
Absolutely.
that's a really good thing, right?
Yeah, absolutely. Fantastic. No, I mean, so it's great to see that you're embracing it and you're developing all these new tools. And I wish you every success with the two that we discussed today. And
Thank you.
look forward to catching up with you, I guess, later in the year. But for now, Joel,
Absolutely.
thank you very much for joining us this morning.
You're very welcome, Trevor. Thank you for the opportunity, as always. I always enjoy talking with you. You do a great job at pulling out the juicy details that your audience is looking to see,
Yeah,
and that's a very maybe underrated benefit to that group, to the people that we're all trying to communicate with. So
yeah.
keep up the
Well,
great work.
thank you very much. I appreciate it. So that's it for this episode of Galbraith in Conversation. If you like this podcast, please like and subscribe on YouTube. And remember to share this with your friends in the industry. You can also watch or listen to this episode and our future podcasts on YouTube, LinkedIn, Meta, X, and all your normal podcast locations like Apple and Spotify.